You want to join the big leagues and learn how to get more out of your hardware. So you're going to step into the world of concurrency in Python. And it's super exciting, but very confusing because there are a lot of options here. And when you go to the documentation on the options, there are options for the options. It is super confusing. We're going to walk through all of them, and I'm going to show you how to break it down in your mind to know when to use which one. So I'm going to start by giving you a roadmap to give you a way to organize all this material in your head. And then we're going to drill down and I'm going to show you where you need to pay attention and where some details are not important. So at a high level, the main question is it CPU usage or I/O that's causing your program to run slow? So if you're doing a lot of image processing or using pandas and crunching the heck out of a data model, that can cause you to use up 100% of the CPU core that Python's running on. Now the key to Python is unless you switch out of the normal mode, you are only ever going to use one CPU. It limits you through something called the GIL, the GIL lock. This says that we're only going to run one CPU no matter what you're doing. Even in multi-threaded, it's still threaded on one CPU. So the only way out of that dilemma is to use the multiprocessing module. So they've got you covered, but you've got to shift gears and program things a different way. What about I/O? This corresponds to reading to the hard disk, saving to a database, talking to a web server, scraping, all these things where you're talking to external data sources. And that has really long lag times in it where your CPU isn't doing anything, but you're just waiting. That involves multi-threading. And they have two options here, which are very different: the threading model and the async I/O module. And so we're going to go through both of those and when you're going to want to use them or when you're not going to want to use them. But get in your head CPU versus I/O. And I have certain programs that I run on AWS Cloud. You'll be paying for 5, 7, 8 virtual CPUs. If you're not careful, you're just going to use one of them. I do a lot of reading databases or pulling stuff from S3. And so I have both kinds of issues in the code, and so I end up having to use both threading and multiprocessing. And so we're going to show you how to do all of that. Here is a big picture map. Doodle this out on a piece of paper and internalize it, because this gives you a roadmap to all the details that you're going to go through, and we're going to create decision trees for when you're going to want to do it. But now think, first of all, CPU is on the left here, and that's going to be your multiprocessing module. Multi-threading is threading and async I/O. Now under that, at least threading and multiprocessing, you have kind of two choices there. One is I'm going to have a single one, or I need a whole pool. I need a whole group of them to do it. And both threading and multiprocessing have this idea of a single unit or a pool. Under single unit, you've got the process class and you've got the thread class. And we're going to go through all the options there. Now under pooling, here again, it gets a little complicated because they've got a raw pool, thread pool class, which is built into threading and multiprocessing. And then they created a whole nother API that abstracts away some of the details that is your pool executor class. So you've got process pool executor and thread pool executor, and we'll go through that. This is the roadmap. You may have to use one or the other or both depending on whether you have CPU issues or I/O issues. This is the big picture, and in each of the following videos, we're going to start going through this and breaking it down. Hope you enjoyed it. Subscribe if you want to know when I come out with new content around these topics, and I'll see you in the next one.